Welcome to college calculus. I have one problem for today. So with this problem I will show you what I mean infinite limit. This is our topic for today. Infinite limit. Before to find the answer to this problem, let me give to you some clues, some ideas, the important to belong to this class. The first one is the definition of what I mean infinity. Definition of limit. Okay, so this is very important idea. So I'm gonna write at some concepts we call. So we have limit when x approach to 8 here, and then all f of x is equals an infinity. So a limit, infinity. So this means here let f be a function defined in both sides of a, except the possibility of itself. Then we have for instance, you have this graph here like this. Let me show you. And then this is we are talking about the vertical lines. You have the vertical lines right here. This is here this is the origin, and then here is x equals a, and then let's do some graph right here. You make the graph like this, this graph. This is y equals, the graph means y equals fx, right? And this is x equals y, and then this is a. This is a and the origin. And the other side we have, for instance, some graph like this. Okay, we are talking about this kind, the limited, the infinity definition of limited is like this. Okay, we have another kind of problem that important to I would like to show you on the graph how looks the graph. So the next one is the definition of let's write a definition of this kind, the limit when we have a limit when x approach to 8, and then of f of x is equals a negative. So like this, right? A negative, so like negative right there. So we have the graph. Let me make the graph something like this. Okay, this is y, this is y, this is x. Okay, let me write the vertical line. You have the vertical line right here, and this is a right here, and then this is x equals a right there, and then make the graph. So the graph should be like this. Graphs look let's use the blue color like this. This graph is y equals f of x, right? And the other side is this is origin. The graphs look like this. All right, something like that is when we're talking a definition of this kind of limit, when the limit when x approach to a, and then f of x is a negative infinity like this. Okay, so let me show another definition of limit in the graph. Is when you have this definition of let's write limit when x approach to 8, and then of f of x is equals like that. In this case, we are talking about the. I mean, let me. It's four different kind of. In this definition, we are talking about actually the vertical line. Yeah, it's better. Vertical line. Let me show you 4 different ways of the vertical lines. The first one, when you have a limit when x approach to a like this, a of f of x equals infinity. So the graph, let me show you the graph right here. The graph, this is y, this is x, it's origin, and then this is the vertical line. We're talking about the vertical line. This is 8. That's the vertical line, and then the graph is look like this, Okay, it's the vertical line. So the graph is like that. So this is one definition. This is the number 1 here and number 1. Let's do another different limited using the vertical line. That's the number 2. We have limit when x approach to a positive right here. F of x equals infinity. Okay, like that. The graph look like this. This is y, this is x, and then the vertical line is right here. It's a look, the graph is look like this. Okay, this is the vertical lines. This kind of limit. Okay, it's number 2. Number 3, let's see number 3. Number 3, we have a limit when x approach to 8, but now it's negative here. So f of x equals negative here. This is negative. So see the graph. See the graph, y, x. This is the vertical line 8. This is origin. And the graph is look like this. Okay? And the last one, the last one, is we see the limit like this. Limit when x approach to 8 positive f x when x so the graph is like, let me show the graph like this. X, y, and then the vertical line. The vertical line is this one right there, 8. Then the graph looks like this. Let's see, like that. Okay. So this, in this definition, one of these four kind of limit must be true. One of these 4 must be true in this definition. Okay. All right. So let's go and solve the problem. The solution of this is close to 3. Close to 3, but longer than 3. Then the denominator x minus 3, denominator is small, positive number, and 2x is close to 6. It's close to 6. So the equation of 2x, the equation of the 2x, the equation of the equation 2x divided by x minus 3, see, is longer positive number. Longer positive number. All right. So this means must to write limit when x approach to 3 positive right there. 2x divided by x minus 3 equals like that. Okay. So likewise, is x close to 3, but smaller than 3, then x minus 3 is a smaller negative number, but 2x is still a positive number close to 6. So this means should be limit. Let me use another color here. Limit x minus approach to 3 negative. So it's another one. So 2x x minus 3 is equals like this, negative. So it's the same thing, but it's a negative. So the graph in the curve, let's see, because I need to make the graph. The graph in the curve y equals 2x divided by x minus 3 is like this. So x, remember that we're talking the vertical lines. So here x equals 3 is a vertical asymptotic. Okay, so let's write a little graph right here. When you have it, this case is like this. All right, let me show you the little graph right here, and then yeah, like this x, and then the asymptote is 1, 2, 3, 4, 5. So in 3 right here, the line asymptotic is right here. So this is x here, x equals 3, right? So this is origin. This is origin here. So let's write the graph. So like this. It's 5, for instance, or whatever. The numbers right there. So the graph is running like this. Okay, and this side, this is equals 3, and then the y is equals 2x divided by x minus 3 right there. So this is our solution. Okay, this is positive, or here as using a negative. So right there, this is the asymptote, the vertical. It's a vertical asymptotic. Okay, very important. Okay, data 2 in our graph right here. So very simple, but this is true. This is the way to find the answer. So find the limit when x approaches to 3 positive. We are talking about positive here. We have right here negative, but we're looking for the positive side. Say 2x divided by x minus 3, and limit when x when it's a negative 2x, and this is right here. Okay, that's the other one.